Hello, my name is Stefan, and today we are going to be walking through how to set up your VR hardware with the VibrationVIEW software. We currently have 4 different pieces of hardware that you can use as a controller in VibrationVIEW. These are the VR9500, the VR10500, the Observer 1000, and the brand new VR9700. First, what we want to do is make sure that the PC is configured to be able to communicate with the hardware. To do this, go to the Windows search bar at the bottom of your screen and bring up the control panel. Once this is opened, select Network and Internet, Network and Sharing Center, and on the left side of the window, change adapter settings. This pulls up a network connections window which shows you all the available networks to you. Right-click on the network that you'll be using and select Properties. It is at this point that you have 2 different options for configuring your PC. The IPv6 option and a static IP address with the IPv4 option. We recommend the IPv6 option as it was added in VibrationVIEW 2024 as a simpler and more secure way to connect your controller to the software. It also helps minimize IP collisions and can often greatly reduce the time it takes for the unit to connect and initialize in the software. If you are to use IPv6, you often can keep these checkboxes as they are by default without having to change anything. However, if you have to use a static IP address with IPv4, you would configure it as follows. Select IPv4 and then select Properties. Make sure you check the Use the following IP address checkbox. This will open up the following text boxes for you to use. In the IP address text box, you can put any Class C subnet. We recommend 192.168.3.10. For the subnet mask, if you simply click in the text box, it will automatically generate. To continue, select OK. In my case, I plan on using an IPv6, so I will just exit out. It is also worth noting that if you are using a static IP address, if you continue to still experience issues trying to connect to your controller, you may have to deselect some of these checkboxes, even the IPv6 option if necessary. In my case, as I said, I will be using IPv6, so I will keep those all selected. Click OK to confirm that setup. It is at this point that we will install the VibrationVIEW 2024 software. If you have a CD for the 2024 software, you can use that to install the version. However, for the case of this video, I will be installing it from the website. Open up your internet browser and type in vibrationresearch.com. Once this is pulled up, go to the red menu button at the top right. In the second column, under Support and Service, 2 down is Software Updates. Select that. You then want to select the VibrationVIEW control software. On this page, it will have you fill out some information. Please do that, check the checkbox, and select Submit. On this page, you can download the latest version of software, as well as some previous versions of software as well. In this video, we'll be downloading the latest version, which at the time of this recording is 2024.1.33. Simply select the link to begin to download the installer. Once this is done, select the download. This will open up the VibrationVIEW 2024 installer. Hit Next, accept the terms. You can keep these folder and file settings by default, they shouldn't need to be changed. Select Next, and then select Install. At this point, you'll be asked if you want to confirm. Click Yes, and it will then continue the installation. Check the Launch VibrationVIEW checkbox and select Finish for it to open the software when you're done. Once the software opens, the first thing we want to do is make sure that the software is configured to be able to hook up with our hardware. Currently, as you can see in the bottom right-hand corner, it shows that I'm in demonstration mode. So currently the software is not even configured to look for a hardware unit at the moment. So what we want to do is go to the top left where it says Configuration. That will drop down and you want to select Hardware. This opens up your hardware configuration window, and as you can see, the network card is selected for demonstration mode at the moment. If we hit the drop down, we can see all the networks that are available to us. As I set up earlier, I want to use the Intel Ethernet network. And as you can see underneath each network, we have an IPv6 option and an IPv4 address. We want to use the IPv6, so we'll select that and hit Apply. As soon as we hit Apply, the software begins looking for the hardware on that network. If we hit Probe, we can also manually do this and see that the controller is in fact on that network. However, since we are still configured for demonstration mode, what we want to do is go to this box right here and hit the drop down where it should find our box. Select that and hit Apply. And if you were in demonstration mode like I was, it will have you restart the software. Hit Yes. And as you can see, it hooked right up to the software. It is at this point that we want to set up our inputs. To do this, go to the Configuration dropdown and select Inputs. This opens up your input configuration window, which allows you to put in sensitivity values for each sensor, as well as turn on the Excel power for the channel that it's on. Currently, I have a 100 millivolt per G sensor on channel 1, and I want to turn on Excel power. If you had a TED sensor, you could simply double-click TEDs, which will autofill all these values as well as the sensitivity. Since I am not using a TED sensor, I had to put this in manually. Click Apply to apply those input settings. Next, we want to go to the Limits tab. In the Limits tab, we can configure the software for a specific shaker. Today, I will be using a Vibration Research VR5200HF. As you can see, that filled in the specific limits values for that shaker. As you can see on the left, we also can put in specific mass values for if I'm testing different products or have different fixtures on the shaker. The software then will calculate a max acceleration value based on the mass and force values that we have set up for the shaker. Click OK to confirm the shaker settings. Before doing any testing, we like to do a system check. What this does is it ensures that the controller and the shaker are hooked up correctly to where we won't experience any errors when running a test. Some generic values to use for a system check test would be a 30 Hz frequency wave at 0.1 inches peak-to-peak displacement. If we turn on the gain for our amplifier and start the test, this will bring the shaker to a 0.1 inch peak-to-peak displacement at 30 Hz. With a displacement wedge on the shaker, we can confirm that the shaker is in fact running at 0.1 inches peak-to-peak displacement. Now that the system check is at full level, if I look at the displacement wedge on my shaker, I can in fact confirm that we're at 0.1 inches peak-to-peak displacement. This confirms that the shaker and the controller are in fact set up correctly, and we can continue on testing. If you have any further questions regarding configuration or any other questions, don't hesitate to reach out at support@vibrationresearch.com or give us a call. Thank you.